Okay, Assalamualaikum warahmatullahi wabarakatuh, and good evenings for respected veterans, Professor Madya, local Nisa, and all colleagues. So, today we are going to present group activity, which is the title is a material for airplanes. For this group, uh, I'm with some colleagues. The first name is Izzat and Najmi bin Muhammad. The second is Tariq Jamal. The third one, Muhammad Arif Hakimi bin Muhammad Ismi, and the last me, Muhammad Nazri bin Ahmad. Okay, for the introductions, aircraft is commonly been used as a citizen to move or to fly over the world. For the information, the structure of the aircraft is the outer surface which cover much of its wings and fuselage. The most commonly used material are aluminium and aluminum alloys, other material including zinc, magnesium, and copper, which is this is the previous of constructing the aircraft, specifically the commercial aircraft. But then, for the future, the improvement in the performance of aircraft has been closely linked to the progress in the materials. Breakthroughs such as those associated with the developments of lightweight, precipitation hardened able aluminum alloy, heat treatable titanium alloy, and more recently, currently the research more on the fiber reinforced polymer was have been made impossible to reduce aircraft structural weights significantly. This has enabled aircraft to fly further and faster, has made commercial flying more economically by allowing larger aircraft and by lowering fuel consumptions.
Assalamu alaikum and good morning to all of you. My name is Tariq Jamal. Today I would like to present my topic, aeroplane materials and its chronology. As we know that high performance aircraft require an extra high strength to weight ratio materials. And as we can see in the figures, the first figure shows, the left figure shows the early days aircraft, means when the Wright brothers made the first aircraft. So we can see in the figure, and the second figure shows the currently used aircraft and airplane nowadays. So a lot of difference between the first and the nowadays airplane. And material used in the airplane to making the different parts of the airplanes. Initially, the wood and iron material used, but due to passage of time and due to a lot of research on the materials of the aircraft, so we nowadays we are using different materials like advanced materials such as titanium alloys, nickel super alloys, special steels, or ultra high temperature ceramics, which are difficult, costly, as well as time consuming to manufacture. And steel and aluminum alloys can be used in the manufacture of ribs, while composite material can be used in the design of the wing, skin, and the control surfaces. These are the chronological of materials of aircraft. We can see that in 1857, Felix, a French naval officer, received a first patent for a flying machine. And in 1874, he had developed a lightweight steam-powered monoplane which flew short distance under its own power after takeoff from a sky jump. And in 1903, the Wright brothers made the first control-powered and sustained flight near Kitty Hawk, North Carolina. According to the US institution, the Wright brothers accomplished the world's first successful flights of a powered heavier than air flying machine. And in 1915, fully metal-based aircraft made by the Hugo Junkers. He was a one scientist, and previously aircraft expert believed that airplanes can only fly with light materials such as wood, struts, tension wires, and canvas. And Junkers thought that differently and believed that heavier materials like metal were necessary to transport passengers and goods. And we can see the right figures. This is the made by the Hugo Junkers. In 1925, Henry Ford acquired the Stout Metal Airplane Company, utilizing the all-metal design principle proposed by Hugo. And in 1930s, the use of wood became abs obsolete, and all-metal aircraft were produced for their durability. And 1935 to 1945, during the Second World War, plastic entered in this scene and replaced the metal parts for rubber parts in U.S. aircraft. After Japan limited metals trade with the United States. In 1970s, plastics continue to lead the future of materials in aerospace and aviation industries for their durability, precision, as well as for its simplicity. For example, in 2009, the 787-8 Dreamliner to have wings and fuselage made from carbon fiber plastics. In 1983, the first significant use of composite material in commercial aircraft was by Airbus in the rudder of the A300 and A310, and after that, in 1985, in the vertical tail fin. And aluminum and its alloys are still very popular material for the manufacturing of commercial aircraft to their high strength at relatively low density. Currently, high strength alloy 7075, which contains copper, magnesium, and zinc, is the one used predominantly in the aircraft industries. And this figure shows the different material used in different part of the aircraft. We can see in the bar chart is steel used 10% and titanium 15%, aluminum around 20%, and rest of the 50% use the composite material, and 5% other material used in the aircraft nowadays.
Hello guys, my name is Izzat. So I will present about question number 2 in the assignment 3 group assignment. So I will present about the class materials properties requirements. So our group choose our group has chosen the aircraft as the element that has been done invention and innovation in 2017. So why is it important of we list all the class of materials and its minimum and maximum requirement properties. So it will describe all the material classes, especially the ground, craft. The second one can be a benchmark for invention. So this is very important that we want the engineer want on the system that this technology. So we the references to them. So the one is to easily do the analysis and comparison with the US software before to do improvement. So next one. So before I go straight about the class of material, so this is the material that is used in the craft. So if you can see from first picture, this is the aircraft A380 is jumbo aircraft. So this is this one from the Airbus A380, which is like has been manufactured in 2010, 2009, something like that. So if you can see the major material used in this aircraft is made up from metal plus materials, right? So if you can see the second picture, it is the Boeing 787. This is the latest model of aircraft from Boeing itself. It can be seen that the major material classes that is used in this aircraft is made up from composite, which is the carbon laminate. So this is the good improvement and invention from the old aircraft, not actually the oldest, but from the old metal, from the metal. Next one, this is the class of material that is used in the invention of the aircraft, of the old, the first one. So we have the best material, polymers, elastomers, ceramic, and previously I just mentioned that right now the latest one from Boeing 787 aircraft, it is made of composite. Two or many, like the basic class of materials combined from one proof material, which is composite. So this is the component and design concern. Why they want to change from these materials to the new materials? It is because we see the I listed this is structure component from fuselage to the spacecraft or to the engine of the aircraft, and the ideas from the shape of the parts and the loading type that occurred to the entire part of the aircraft and its constraint. Constraints mean the major thing that we want. We want in that class of materials. We want the maximum vacuum resistance or the strength, or what actually the temperature or the strength that we want that kind of materials to be used in the part of the. So this is the material properties of the requirement material properties of the metal, which is specifically the newest aircraft. It's used alloy like platinum alloy. So this, if you want to use alloy, what is the minimum and maximum requirement used for the to be used in the aircraft? So we have if you want to magnesium, so we have the minimum of 1.7 density to the 1.8 and continue to the other alloy to the end alloy. Therefore, so it's elastic modules. So this is the very important data used to the engineer to use improvement of the aircraft. Next, this is the specific stiffness and buckling resistance. We have the specific stiffness and specific buckling resistance. So we can see the technical is quite a good one, which is it have specific stiffness, higher specific stiffness, also the specific buckling resistance. Next one, we have material properties of alloy metals and pros and cons. So why we use this kind of alloy, this type? So compares like basically chemically, aluminum, platinum, and stainless steel. You can see the pros and cons there. So type of aircraft part. So this one is ground composite and combination of the composite. So from my reading, CFRP has a quite good competitive with the aluminum alloy because the value of stiffness between them is quite similar. But the CFRP, which is carbon fiber reinforcement, it has high value of specific buckling resistance. So that's why you see from the Boeing 787 bodies, it used composite type of material using the slash moving part. So because it has the highest specific buckling resistance compared to so this is the references that I make. So thank you so much.
Okay, now let's move to the question 3, which is the failure that may happen to the aircraft. So I would like to point out two failure, which is fatigue and corrosion. So first is a fatigue failure. Fatigue is a common problem with all metal airframes. The metal elements of planes deteriorates over time as a result of repeated flight cycles and frequent use, and they will eventually require attention and repair. The aircraft must withstand both lift and drag in flight, as well as their own weight on the ground. So firstly is a fatigue failure. There are some factors that contribute to this failure, which is pressure and lack of inspection. For an aircraft, the change of pressure is a common factor that it will experience, especially when departs and landing, where the aircraft component will experience pressurized and depressurized. And next is a lack of inspection. Structural failure occurs when aircraft fatigue is not detected early enough or is left untended. Since most fatigue cracks are invisible to the eye initially, it makes them particularly challenging to detect. So there is high chances for the misinspection to occur. Okay, moving on to the next slides. This is how a failure mechanism how a failure occur. So starting with the continuous stress, and then it will lead to the premature crack and crack eventually. And then lastly, there is a high risk of fuselage skin to peel off. So this is some example of stresses and forces that occur at the aircraft. So there is hoop stress that occur during landing and depart due to pressurize and depressurize, and also axial stress. And next, bending, which is occur also during the depart and landing. So next is corrosion. Aircraft corrosion is rust that appears on aircraft's metal surface and components. It happens when an unprotected metal comes into contact with oxygen in the air. A variety of factors contribute to aircraft corrosion, including acid and pollutant exposure, poor preparation prior to painting, and high levels of moisture. So there are a few types of corrosion, which is surface corrosion, dissimilar corrosion, stress corrosion, intergranular corrosion, and fretting corrosion. So that's all from me.
Okay, for the conclusions, industries are switching to more advanced material. They are struggling to resist more on the advanced material, focusing on the aircraft structure. Research are being carried out to use a composite in structural parts in aircraft like the wings or fancal, or part of the element in wings. Material property of making airplane could be considered to be high strength to weight ratio material. It contribute to economically, especially for fuel saving. As we know, the price of uh, aircraft fuel is a bit costly. Aircraft corrosion is rise that appears on the aircraft metal surface and components happen when an unprotected metal comes into contact with oxygen in the air. Lastly, a variety of factors contribute to aircraft corrosion, including acids and pollutant exposure, poor preparation prior to the painting, and high level of oxygen. I think that's all from our groups. Thank you very much for the attention. Assalamualaikum.